No, back in the 1980s, something absolutely huge happened in the world of artificial intelligence. It was the decade that AI really stopped being just a pre-programmed know-it-all and started becoming a student, one that could actually learn on its own. Today, we're going to dive into how that massive transformation happened, and you'll see why it's the foundation for pretty much all the AI you use every single day. So think about that for a second. Before any of the mind-blowing stuff we see today was even possible, AI had to master one single fundamental skill. It had to learn how to learn. And believe me, the journey to get there was anything but simple. By the time the early 80s rolled around, a lot of the initial hype around AI was kind of fizzling out. The way they were doing things, building these systems based on super rigid hand-coded rules, well, it was turning out to be a dead end. Researchers were realizing that to get to anything like true intelligence, they needed a completely different game plan. So on one side, you have the old model, these expert systems. The best way to think of them is like an incredibly detailed instruction manual with millions of if-then rules. They were great for very specific, predictable jobs, but they were also super brittle. The second they saw something that wasn't in the rulebook, they just broke. But on the other side, a new vision was emerging, an AI that could learn and adapt, kind of like a human student, just by looking at the world around it. And this huge problem, this wall they'd hit, it sparked a truly revolutionary idea that would completely redefine the future. The question became, what if, instead of trying to program intelligence line by line, we could build a machine that learns it? And this new approach got a name, machine learning. The core idea was a total break from the past. Instead of a programmer painstakingly writing out every single rule for every possible outcome, they could now just feed an algorithm a ton of data and let it figure out the patterns and rules for itself. You know, it's the difference between memorizing a phrase book for a trip versus actually learning the language. One is limited, the other lets you handle anything. This quote just absolutely nails it. The whole AI community was starting to get that real intelligence isn't about having a perfect set of logical rules. It's about being able to navigate the messy gray areas of the real world. And for that, you need to learn from data with all its imperfections and nuances. Okay, so what was the secret sauce? What were the key ingredients that made this whole revolution possible? Well, in the 1980s, you had this convergence of tech and theory that created the absolute perfect storm for machine learning to just take off. It was really these three key things coming together at once. First, artificial neural networks, an idea inspired by the brain that people had mostly given up on, were suddenly back in a big way, with new methods to actually make them learn. Second, the field started embracing statistics, letting AI think in terms of probabilities, not just black and white logic. And finally, the computers got fast enough. We finally had the raw hardware power needed to run these incredibly complex calculations. But the real game changer for neural networks, the thing that unlocked it all, was an algorithm that came out in 1986 called backpropagation. Okay, so imagine you're teaching a computer to recognize a cat. You show it a picture and it guesses dog. You say, nope, wrong, and you measure how wrong it was. Backpropagation is basically the magic trick that sends that wrongness signal backwards through the network, telling every tiny connection, hey, tweak yourself a little so you're more likely to guess cat next time. Now do that millions and millions of times, and the AI gets scarily accurate. Now, this new approach kicked off a fierce, almost philosophical debate. On one side, you had the symbolists, thinkers like Marvin Minsky at MIT, who were convinced that real intelligence was all about logic and manipulating symbols. But on the other side, you had the connectionists, like Geoffrey Hinton, who believed intelligence just emerges from these huge, messy networks of simple connections, just like in our own brains. This was way more than an academic squabble. It was a battle for the very soul of AI. So that's the theory, but what did this actually do? What was the real-world impact of all these breakthroughs? Well, the stuff that happened in the 80s didn't just stay in the lab. It laid the direct groundwork for technologies that are now completely woven into our lives. The results were almost immediate, and they were profound. All of a sudden, we had systems that could read handwritten zip codes on mail for the Postal Service, or recognize simple voice commands. And in business, companies started using this new thing called data mining to understand what their customers wanted, to predict trends. Machine learning was no longer just a cool idea. It was a powerful tool solving actual problems. And honestly, the legacy of the 80s is still playing out right now. You can draw a straight line from then to today. The data mining of the 2000s, the deep learning revolution in the 2010s, that's what powers your phone's camera and your Netflix recommendations. And yeah, all the crazy generative AI that's changing our world in the 2020s. The DNA of all of it goes right back to that pivotal decade. So yeah, the 1980s was the decade AI learned how to learn. We went from trying to handcraft intelligence, line by painful line, to cultivating it with data. The question now isn't just about what we're going to teach these machines next. As they get more and more capable, you have to start wondering, what are they going to teach us?